again, and we're going vertical, and we're going horizontal. That's right, horizontal shifts of algebra. Today we're going to talk about stretches and compressions. I'm going to try to make it as quick as I can. So here we're at the stretches and compressions. Yes, vertical stretches and compressions. That's what we're going to be doing. We learned vertical, that we could multiply things to the algebra function itself to get it to vertically stretch. Today we're going to also learn that multiplying things inside grouping symbols can create that same effect, stretching and compression. However, horizontal stuff is kind of backwards from what we learned with vertical. If it's inside, if it's a horizontal thing happening to the geometry that I want to do, like I want to take the left and right positions of the artwork and I want to stretch it horizontally, or if I want to take the left and right portions of the artwork and compress it, well, how I do that is multiplying inside grouping symbols, so it's a horizontal thing. But I do it opposite of what I learned with vertical. Numbers larger than 1 that I multiply compresses. Where vertically we learned that it stretched. They got taller, but it doesn't get wider when you get bigger than 1. It gets skinnier. It kind of goes opposite of what you learn or what you had thought. On the same thought that when you multiply something between 0 and 1, it horizontally stretches. It gets wider. So it kind of goes opposite of what you think. So again, to demonstrate that algebraically, we can look at the parent graph that we have been playing with, and that is the parabola. Again, parabola. I'll clear that out. And we're going to look at multiplying things. Again, there's Papa, x squared. But to do things horizontally, we've got to do it inside parentheses, and so what I'm going to do is multiply, because I want it to stretch or compress, and I got to keep it in the family, so it's got to continue to be squared. But again, if I'm going to do it horizontally, I've got to do it inside a grouping symbol, inside a parenthesis in this case, and staying in that family of parabola, so it's squared. 3 is larger than 1. Vertically, we saw that stretched it, it got it taller. But with horizontal things, it kind of goes opposite of what you think. So instead of getting wider horizontally, it's actually going to get skinnier, or in essence taller. Again, these things look very similar. So we've got the two functions up here. Let me see if I can hit graph and we'll see what it looks like. There comes Papa. And sure enough, there is 3x inside a parenthesis. Everything being squared, it got skinnier. Went on Jenny Craig. Yeah, that's right. We got in those lines of Jenny Craig, and I see your mom. Oh, no, that's just kidding. But it got skinnier. From all this holiday eating, it got skinnier. How did we do that? We multiplied, but we multiplied inside the grouping symbol, in this case inside the parenthesis, and larger than 1 made it skinnier. The multiplicative number, the scalar that we multiplied to was larger than 1 and got skinnier. If we wanted to make it wider, then again, with horizontal, we'd go inside. And if I wanted to make it wider, then I would multiply it by something between 0 and 1. So here's an example. Between 0 and 1, 0.1. It's larger than 0, smaller than 1. It's inside parentheses. It's being multiplied to the x. And so it's going to have a compression or stretch effect, but let's see which one it is. Oh, it got much wider, right? So that's, I'm going to give another look so you can see that happening a little better. So there's a 0.5. There it is, wider than Papa. Okay? So again, algebra, we see that stretching and compressing, stretching it horizontally, compressing it horizontally, is done by multiplying, but it's done inside the grouping symbol, inside that parenthesis, the square root symbol, the absolute value, regardless of what paragraph you're working with, those horizontal things can happen. Hey, you have got just one more lesson. Oh, that's all there is to learning how to algebraically transform your picture into the geometry and the artwork that you want. So we'll talk about that in just a moment. Thanks.